Hi everyone, it's Calculus by Christee, and in this video we're going to look at FRQ number 2 from the AP Calculus AB exam. Alright, here we go. So, problem number 2 is about Stephen swimming back and forth in a pool. And the first question says to find all times between 0 and 90 when Stephen changes direction. So a particle, or in this case a person or an object, changes direction when velocity changes sign. So we're looking on the graph where velocity is 0 and velocity changes sign. And when I say looking on the graph, I mean looking at the graph on our calculator, because problem number 2 on the AP Calculus exam, you could use a calculator. So what I did is the very first thing I would do is I would plug this into your y1. What I mean by that is you are pressing y equals and you're plugging in the given function into your y1. And then because I want to look from 0 to 90, I then changed my window to be from 0 to 90 here. And this is what it looks like on the graph. So I am looking for this spot right around here where velocity equals 0 and velocity changes direction. What I like to do to calculate this is I like to plug in y equals 0. It graphs this horizontal line, and therefore I can press second trace to calculate the intersection. Pressing enter 3 times, I can see that the intersection occurs at 56. So therefore my answer is at t equals 56 seconds, Stephen changes direction because velocity changes from positive to negative, and we saw that in the graph. Part B says to find Stephen's acceleration at 60 seconds. Well, we are given velocity. Acceleration is the derivative of velocity. So when I find acceleration, what I like to do is I like to connect it to what I am given in the problem. If I need to find a of 60, that means I'm finding the derivative of velocity at 60. Again, because we have plugged in our function into y1, well, if I want to find the derivative, I simply go back to the main screen. Press Math 8 to get the derivative, and I love this. I can just press alpha trace to get y1. I don't even have to type the function over and over and over again. It's my favorite thing, and I am finding the acceleration at 60, and I get that value right here. And it did say to indicate units of measure. Well, velocity is meters per second, so acceleration is meters per second squared. And then the next question is Stephen speeding up or slowing down? To determine the answer to this question, you must compare the signs of velocity and acceleration. So we already see that acceleration is negative at a time value of 60. So we need to calculate velocity, which is the function given, at 60. Once again, I'm using my trusty calculator, and I can simply go to alpha trace, select y1, and evaluate that at 60. Again, it's my favorite thing. Plug your function into y1 so you don't have to keep typing it over and over and over again. We can see that velocity is also negative. If acceleration and velocity are the same sign, either both positive or both negative, our person, in this case, is speeding up. And once again, I said because both acceleration and velocity are negative at a time value of 60. Let's look at part C. Part C says to find the distance between Stephen's position at a time of 20 seconds and a time of 80 seconds. To find the change in distance, or displacement, you are finding the integral between those two time values of velocity. And for that, once again, I just use the calculator. Again, velocity was under my y1, so with a simple math 9, I can go from 0 to, let's see, what was it? It wasn't 0, it was 20 to 80. Let's try that again. So I need to go down here and go from 20 to 80, and that's the velocity function, so I've got it up here as y1, and there we go. All right, that's going to be our distance between those two time values. That's how I got that. And this was meters because you were finding distance. The last part was to find the total distance. To find the total distance, you take the integral of the absolute value of velocity. That'll give you the total distance traveled. And because we're going from 0 to 90, those would be the lower and upper bounds of my integral. And once again, I need to find the absolute value. And I just realized that I forgot the second absolute value symbol. Whoops, let's put that one in right there. Not as straight as the one before, but there we go, the absolute value of velocity, and I got 62.164 meters. Once again, I'm doing that on the graphing calculator. I'm going with a math 9. I'm going from 0 to 90. And now I need not just v of t, but I need the absolute value. So I'm going to math, number, absolute value, and going back and choosing that function. And we can see we get this value right here, and that is the same value that I have here, 62.164. And again, it's meters because you are finding the total distance. All right, everyone, that is question number 2 on the 2023 AP Calculus AB exam. I hope you found this video to be helpful to you. If you did, please make sure to give it a like and subscribe so that you can see the other videos that I will post of questions 3 through 6 of the rest of the exam. All right, everybody, I hope you have a good day, and we'll see you in the next video.